So, the next part of Rooney in this moduluni. I ran out of ideas to intro. Let's just carry on.
Alright, yeah. Is how you get from everything to everything else.
Yeah, synthesis. So you want an end product. How can you get to it with these simple starting products?
Yeah, you get one product, a series of reactions, gets your last thing. Well, how do you do that?
Well, it's easy. I mean, I have you at the minute.
Right.
I want a dairy milk chocolate bar. I guess I could like churn you off in some big blender, but that would be really expensive. So what I'm going to do is a different step. I'm going to give you this crisp £5 note with the Queen's face on it. That's the important part. I'm going to give you that. I'm going to say, go to the shop, buy me a dairy milk bar.
I don't really want to.
It's not really an option. It's a chemistry course. OCR would fail you if you didn't.
Oh, really?
On your bike.
Oh, okay.
On your bike. And this basic principle can be applied all through chemistry. So you want an end thing, you've got to synthesise stuff, and it always works.
Shop's shut.
Yeah, well, it nearly always works. So, yeah. So let's say we start off with a halogenoalkane. So I'll call it X to H, where H is a halogen and X is, you know, the rest of the stuff. So these can be an alkene, an alkane, whatever, but it's got a halogen attached, normally a halogenoalkane.
Right.
And what if I don't want that? What if I've got some of that and I don't really want it?
Okay, but what said when?
What if I want an alcohol? We'll start with that.
Alright.
An alcohol. I want an alcohol.
Okay, well you want to get rid of that halogen. You want to add an OH to it, basically.
Yeah, basically you want to get rid of this and keep the chain, but in place of the halogen,
yeah.
OH.
So you could add H2O or you could add NaOH, both under reflux.
Yep. So I'm gonna do that. You can have NaOH or you can have H2O. And that goes to, I'm going to say OH, just alcohol. It's just an alcohol.
Yeah. And you have to mention it's under reflux to cook as well.
Yeah, absolutely. Reflux is important.
And that would give us an OH group. But what if we had our halogen alkane still? We're just sort of chilling with it.
Yeah, got it in a bottle.
Don't want that either way.
You still don't want it, no.
No. I want that. What do I want? You know what I mean, do you?
I know what you mean. I know what you mean. It's the amine.
Yeah, I want an amine.
Yeah.
Okay. How do I do that?
Well, again, another simple step. You can add ammonia.
Yeah.
Or NH3.
Which is ammonia, so that's handy.
It is indeed. With ethanol. Ethanol is important. Cold aqueous ethanol.
That's well tasty. And that will give us some sort of amine, which is pretty.
Yeah, some sort of thing. Like that. It gives us that. The X thing, but the halogen's been replaced with an H2.
That's pretty handy.
That's another thing we can do.
Okay.
Let's focus more on this route, okay? We've got this OH, and depending on where the halogen was when it was replaced, we could have a primary or a secondary alcohol.
We could. So, yeah,
primary or sec. I'm going to put sec.
Sec, not co-sec, sec, cot,
arctan.
Just sec.
So we've got secondary and primary.
Okay, so what can we do to primary?
Well, from AS we know that we could heat it under reflux with acidified potassium dichromate.
So let's do that. That sounds like a bag of fun.
Yeah, let's distill it first and do it in two separate steps rather than doing the reflux, because you can do two different things with primary.
You could. Okay, so it's just oxidise it then with...
Yep, just oxidise. So at this point we're distilling it. Primary means the OH is at the end. So first what it's going to do is it's going to form an aldehyde. It's going to have a double bonded O at the end. So we've got a C double bonded to O as our product. And as you know, if we were to heat it under reflux, that would be like another step. It would go down. And again, it's under acidified potassium dichromate, oxidised. And this time it will form a carboxylic acid group. As we know, heating under reflux, this is all AS revision. So it's going to form a C double bonded to O to an OH, so a carboxylic acid group. Alternatively, we could do the same thing in this direction.
Okay.
We could oxidise, so ox.
Yep, and just give us a ketone.
K2Cr2O7, H+. And this, it will give us a ketone, so I suppose I should, with this one, I'll put X either side, add stuff either side. That one's an aldehyde, that is at the end. You should know that from AS. So that's a route we can go. Can we go any further? Well, we've got this. We can do other stuff with carboxylic acid. Now this is the A2 stuff.
So making an ester.
We can make esters. So, but I've noticed something. What do we need to add to a carboxylic acid to make an ester?
An alcohol.
An alcohol. But we have an alcohol.
What's over there?
So what do we need to add to an alcohol to get an ester?
Carboxylic acid, right?
So these sort of have a common goal, if you will. These could both go to an ester of some description.
Of course, this one needs some sort of alcohol, and this one
needs some sort of carboxylic acid.
and together they make beautiful harmony of fruitiness.
Yep. Both of these are under reflux.
Oh, of course, yeah.
To form this beautiful ester. And in the previous video to this, we've done things with esters where you can break them up in 2 different routes.
Yeah, we did. So we've got 2 different types of hydrolysis we used.
Yep, so we've got the acidic one, so I'm just
Yeah.
going to put water. It's water off H plus ions.
Yeah,
It's
yeah,
just
whatever.
the general thing. And that forms the carboxylic acid and alcohol again,
Yeah.
plus alcohol. So it's basically reversing this. But if we had this and we added this, we're going back to it again. It's just it's another synthesis way.
Then if we do the basic way, the alkaline conditions,
We get a carboxylate
which is well swish,
and an alcohol.
we do.
So this is a bit of synthesis going on right
Yeah.
here. So we started off with this halogenoalkane. We've got all the way to a carboxylate and alcohol.
Yeah. And we went back a bit, and we made more fruit, we made our money, selling perfumes.
Indeed, indeed. Now, some of these are reversible, so the shops would never shut. There'd be 24/7 hour shops.
True, it's true.
So we could go backwards. We could reduce this with NaBH4.
You can do the same on the other side. I mean, I could stretch it away.
We could indeed, and we could reverse that one. A lot of these actually aren't reversible, as far as we're concerned. There's a lot of these
maybe
aren't
other products you can add, but at puree level, yeah, they are as they stand.
So this is a summary synthesis. So the only question I have is, where's my money?
Now,
Knew those shops were open.